So for this question, again, you look at this denominator, and this denominator looks deceptively the same as one of our trig derivatives, specifically the arcsecant trig derivative. And so you kind of see that and you say, okay, well, that really looks like an arcsecant derivative. And that rule that we use when we do our integration is going to be that the integral of du over the absolute value of u, square root, and then our u squared minus a squared is going to equal 1 over a secant inverse u over a plus c. So that is a rule that we have to memorize in order to be able to integrate this. So once we have that rule as our starting point, we then have to match up our current integral. So our current integral is 1 to the square root of 2, and then dx, absolute value of x, square root x squared minus 1. Okay? Now, when you look at this, you'll see the matchup here that your u would be equal to x, and that matches here as well as here. Then your du would be equal to dx, so that matches very nicely, and your a is equal to 1. So with that as your match for the integral rule, you're just going to plug in. So you'll have 1 over a, which is 1, secant or arcsecant u, which is x, over a, which is 1. Now again, we're not going to put the plus c because we do have bounds. So we have the bound 1 to square root 2. So now that we have it integrated, we'll then plug in our upper bound minus our lower bound. So we'll start with the secant inverse square root 2 minus secant inverse of 1. Now remember that secant inverse, the question that you're asking yourself is what angle, so what angle theta, secant of that theta gives us square root of 2. And to answer that question, you're really asking yourself, if you think about the square root of 2 as over 1, what angle's cosine is going to be 1 over the square root of 2. And if you remember from trig and you rationalize, that is the same thing as saying what angle cosine theta is equal to square root of 2 over 2. Okay, and of course that angle is going to be pi over 4. So the square root of our arcsecant square root 2 gives you pi over 4, but you still have to subtract that from your secant inverse of 1. So to do that, you're going to have to go through the same little song and dance here, and I kind of feel like I need a different marker in order to go through the same song and dance. But what you're going to have to ask yourself is what angle gives you 1, and of course that's going to be cosine theta is equal to 1. And so if you look at where cosine of theta is equal to 1, that is going to be at 0. So that gives you pi over 4. And again, we're getting pi over 4 because our upper bound evaluated to pi over 4, and then we subtract that from our lower bound, which just evaluated to 0. So your final answer is going to be pi over 4.